We saw that the derivative of the sum of two functions, f of x plus g of x, is just equal to the derivative of the first function plus the derivative of the second function. How about the product? What is the derivative of the product of two functions, f of x times g of x? You might guess that it should work the same way. Shouldn't that just be the derivative of the first function times the derivative of the second function? Well, let's look at an example. Let's say we have the derivative of x squared times x plus 1. Now, you might think, should that just be the derivative of the first function, which is 2x, times the derivative of the second function? What is the derivative of the second function? Well, first you do the derivative of the first piece, which would be 1, plus the derivative of the second piece, which is 0. And so you end up with just 2x. But that's not right, because x squared times x plus 1 is x cubed plus x squared. And when we take the derivative of x cubed plus x squared, we don't get 2x. Instead, we get 3 times x squared plus 2x. So something went wrong here. The derivative of two functions multiplied together is not just the derivative of the first function times the derivative of the second function. In order to figure out how to do this, let's go back to the limit definition of derivative. We'll calculate the derivative of f of x times g of x by taking the limit as h goes to 0 of first plug in x plus h. So you get f of x plus h times g of x plus h minus, plug in just the x, f of x times g of x. And that's all going to be over h. Now, at this point, you might feel kind of stuck. Like, what could you possibly do? But we can do a little trick. What I'm going to do is I'm going to alter this fraction by adding and then subtracting the same thing to the top. Right? If I add 5 and subtract 5, I don't change the function. So I can add and subtract the same thing to the top without changing the function. So let's do that. I'm going to add an f of x plus h times g of x piece, and then I'll subtract an f of x plus h times g of x piece. So notice I've just added and then subtracted the same thing. So I haven't changed the fraction at all. But now that I've done that, I can begin rearranging terms. That gives me the limit as h goes to 0 of, I look at this and I say, okay, well, these both have an f of x plus h and an f of x plus h. So let's put those two terms perhaps close. Oh, this one does too. So maybe I should put those close. So let's do this. Let's take the first term. Let's take the f of x plus h times that g of x plus h. So I'm taking this first term here. And then I'm just going to stick right next to it the last term, this minus f of x plus h times g of x. And then I'm going to take this third term, this plus f of x plus h times g of x, and then I'm going to subtract off the second term, minus f of x times g of x. And that's all over h, and that's all over h. But look what you have here. Here I had an f of x plus h times something minus an f of x plus h times something. Let's pull out that f of x plus h. I can pull out that f of x plus h out front. And here in both of these, I have a g of x. So let's pull out that g of x. I'm just going to pull out that g of x. And what am I left with? Here I have g of x plus h minus g of x all over h. Well, while that piece, as my limit as h goes to 0, This fraction is just going to be the derivative of g. And in front of it, I have f of x plus h, but as h goes to 0, that just becomes f of x. And then I have plus f of x plus h minus f of x all over h. Well, that's just the derivative of f. Then I have times g of x, times g of x. So here's the correct derivative. If I want to take the derivative of f of x times g of x, I need to leave the f the same, times it by the derivative of g, plus take the derivative of f and times it by g. Let's think about how that would work out with this function. If I'm trying to find the derivative of x squared times x plus 1, this tells me that I can do it by leave the first function the same, x squared, times the derivative of the second function. And we already saw the derivative of the second function is just 1. Plus, take the derivative of the first function, which is 2x, times, leave the second function the same, times x plus 1. And if you simplify this out, notice you get an x squared plus 2 more x squareds, so that's 3x squareds, plus you get a copy of 2x plus 2x. That is, you get exactly what you're supposed to. So the correct way to take the derivative of a product is not just the derivative of the first function times the derivative of the second. No, you have this more complicated process. I'll call this the product rule, where you hold the first, take the derivative of the second, plus take the derivative of the first, hold the second.